Okay, our goal today is to be able to solve logarithmic equations. All right, you've learned that logs are the inverse of exponentials. When we did exponential equations, we would log both sides to get that unknown out of the exponent place and be able to solve. So when we saw something like 2 to the x equals 6, when you see that x up there in the exponent place, you instantly need to think log. Well, today we're going to see equations with logarithms in them. So you need to instantly think exponentiation. We want to raise each side so that it's the exponent in order to cancel out this log and leave us with an equation we can solve. So if you need a title, this is logarithmic equations. And we're just going to do examples. There's really not much notes-wise other than these examples. The one note is we're going to undo this with exponentiation. Okay, so a few of these examples at the beginning are almost too easy. If you have log 20 on both sides, then basically you can just ignore it. All right, the log of one thing, if the bases are the same, log base 20 of negative 4b equals log base 20 of negative 2 plus 6. If this is going to be true, then negative 4b must equal negative 2b plus 6. Technically what you did there was you did 20 to the left equals 20 to the right, but if you have the same thing on both sides, you can pretty much just ignore it. All right, so now we would solve this by adding 2b here, adding 2b here, and getting b equals negative 3. So we won't spend a lot of time on ones that have the same log on both sides. Number 2 there's another example. If you have a log base 6 on both sides, you can just ignore. Now, what we do want to do is spend some time on ones like this. What if we have a log base 8 on one side only? When we were doing exponential, I stressed the fact that you needed to isolate the power, get the exponential expression by itself, and then log both sides. I want to end up doing 8 to the left equals 8 to the right, but this needs to be gone first. You cannot do that until it's isolated. So let's isolate it like this. Minus 8, minus 8. The left side, log base 8 of m plus 4. And now the right side is negative 2. All right, so now if your entire left-hand side is just one expression, that's a logarithmic expression, I can do 8 to this side equals 8 to this side. All right, this is kind of like that second or first step from exponential, where you probably in the long run won't end up writing that step, because 8 to the log base 8 of something is just that something, and that might save you a step. Okay, so I have eliminated the log, which is a good spot to be. And right now what I have is m plus 4 equals 8 to the negative 2. Remember, 8 to the negative 2 is 1/64. All right, so I need to do basically 1/64 minus 4. There's a couple ways we could approach that, but basically it is negative, once you get your common denominator, it's negative 255 over 64. All right, 256 over 64, that's equal to 4. So we are on the negative side, but we're 1/64 less than that. Okay, so that's how we're going to deal with it if we have just log on one side. There's a few more examples. We have log on both sides there. The purpose on 5 is you just ignore the logs and you end up with a quadratic equation. That's not really the purpose right now. Similar with 7 and 9. Let's try to get to more that we need to solve. Okay, let's do 15. All right, log base 11 of negative 6a minus 2 equals negative 1. All right, isolate the log expression. add 2 to both sides to do that. Log base 11 of negative 6a. That's what that means. That's a little confusing without parentheses around it, but we are taking the log of negative 6 and a together. And now the right-hand side is 1 after I add 2 to both sides. The log expression is isolated. The base of the log is 11. I'm going to write it this time. This is the step right here that you might not always write, but write it until you're comfortable. All right, 11 to the left equals 11 to the right. If the left and right-hand sides are equal, then 11 to one of them must equal 11 to the other one. What you do to one side, you do to the other. 11 to the log base 11 of negative 6a is negative 6a. That's why we choose to raise the 11, so the left-hand side will just be negative 6a. Back in pre-algebra, when you learn to do this, why do we choose to do plus 2 here and plus 2 here? Well, we choose to do that so that we're left with only x on the left. All right, and there's more steps inside, just multiplying by negative 6 here, but we choose to raise it up above the 11 so that we are left with just negative 6a. And on the right, it's nice and convenient. 11 to the first is 11. Divide both sides by negative 6, and we get negative 11/6. All right. After you raise it up to be the exponent with a base of 11, the log is gone. That was the goal. All right, let's try. These are not going to get a whole lot more complicated than that. Let's do, let me find one that might look slightly different. Okay, let's try 20 here. Okay, I see log base 9. That tells me I need to do exponential 9 to the left equals 9 to the right. But I'm going to make sure that I isolate the log expression first by adding 1 here and adding 1 here. Log base 9 of n minus 7 equals 0. So it's making me a little worried. That 0 over there is something gonna happen. I'm not sure. I'm a little nervous with the 0 because I know logs can never equal 0, but this particular log graph has a minus 7. So if you think of the graph, it has been shifted to the left 7, so it will cross 0 at some point. If you see that 0, just keep on proceeding as usual, and if you might get no solution at some point, but that's not going to happen here. My log expression is isolated, so 9 to the left equals 9 to the right. Make sure at this point you are comfortable with 9 to the left equaling that. That's my next step. All right, 9 to the left cancels out the log base 9. 9 to the right is just 9 to the 0, which is 1. Add 7, and there we go. Okay, so this one I always say when you solve an equation, you should sub it back in and check. You can do that, especially if your calculator is newer and will do log base 9. It's a little bit trickier with an older calc. You could still do it, but if we substitute 8 back in, we're going to get a true statement. Actually, it's log base 9 of 1 when we sub it back in is just 0, and you get negative 1 equals negative 1. But the point's the same. You should always check any of your answers when you solve an equation. So there are more around. So just pick any of those numbers. I'd say pick a couple of these towards the end. 21, 22, 17, 18. Pause and write them down if you want a little bit of extra practice. And then here is a key for all of those. All right. With this flipped class, sometimes you might not get as much practice as you need. So there are a few extra problems, a few extra answers. Never, ever be short of practice. You can have as much practice as you need. All right, so there's logarithmic equations. Exponentiate to get rid of the log. I'm out.